Hi, welcome to another episode of the DigiTeacher Podcast. In today's episode, I'd like to look at a fun project that you can put together in a coding class using Scratch and the video camera, the web camera on your device. One of the reasons I like this assignment, not only because it's fun and engaging for students, but also because it's something which doesn't involve just coding on an online platform. It's something which reaches into the real world and gives you a glimpse of the kinds of applications that you might be able to put together yourself very easily. It's a very simple project and yet very effective. Most students will take about 10 minutes max to put the project together, and then that gives them time in class to play with the project and look at each other's projects, and then also extend it and modify it. So I'll unpack some of those issues as I walk you through what the project is. In these sessions where I present little projects that you can do with your class, I'd also like to look at the kind of reasons why doing it and some suggestions of pedagogical approaches that you might use. Overall, I think it's quite important, wherever possible, to use free resources. Money is very, very tight, and I think it is important that we try to find effective things which can be done on a real budget. So your school might find that there are some enterprise solutions that really work for you because it offers the kind of security and the features that you need for a program that you're introducing. But programs like Scratch, which are free, I think can be hugely effective because they have a ton of functionality to them. Students very often are already familiar with Scratch. So if you're teaching, middle school level or something like that, and you have students coming from many different feeder schools into the high school, then what you're going to find is that some will have used Scratch, some won't have used Scratch, some will have done coding, some may not have done any coding. And so what you need is projects which kind of work through fundamental concepts and introduce them to working within a platform. I think it's also important not to just use one program, one platform. So I don't only use Scratch, I use the microbit platform as well. And that has different block coding, and then I try to move from the block coding to Python so that they're ready from grade 10 level for text-based coding. And I think the advantage of using different platforms over the course of the year is, first of all, it does away with some of the boredom. So if you're just using the same platform every week, I think it can get a little bit stifling. You get a bit too used to it and it loses its edge. But also because what you're then focusing in on is the coding concepts, the computational thinking, and for example, using a while loop, using a conditional statement. You don't get kind of tied into one particular computing language, so that if you go on to university level, you're expected to do C++ and Python and Java, and you're supposed to be fluent in all of those languages. So I think it's important to have an agnostic approach, to use different platforms to bring a little bit of freshness and newness, and also to learn computer programming concepts rather than a particular computer language. So the project that we'll be looking at uses the web camera in Scratch. So you need to import an extension that gets students used to importing extensions, and then you turn the video on and you have sprites on the screen, and when there is movement on the screen in the same position as the sprite, then it will hide the object and it will give you a score. So it's a kind of catching something with your hand, moving around the screen, catching it, or it's a sort of bobbing for apples. You can use your mouth to try and eat the apples on the screen. And it's a very simple project, but it's great fun, and the main concept being introduced in this is the ability to use the web camera in an application that you are designing. So overall, what I think it gives students is a sense of agency, that they can code something in a window, and then it has an effect in the world, something that they can physically do with their computer, creating their own game. Not just that you play with a click mouse, but you play it with your body. It's a bit more physical, it's a bit more out there. If you tie that to creating projects which are kind of useful, so once you have these foundational projects in place, you can build towards a project where the students use the skills they've learned, the ability to use the web camera or to use Google Teachable Machine, for example, to build an application that would be useful in the school. So I'm going to be doing a series of 3 of these videos. The first one is using the web camera. The next one is using Google Teachable Machine, and then it's putting together a project in which students code something of their own which is useful in the school. So let's get into the project, let's get into Scratch, let's see how it works. So if you go on to Scratch, scratch.mit.edu, I'll put the link below, and you probably should get an account so that you can save the projects that you create. You get the students to sign up to the site as well, create their own accounts so that they can save their work. And when you click on Create, it opens a new project, and it opens up pretty much with this screen. So I've already attached the video to this so that you can see me inside the Scratch window. Otherwise there's a conflict between me using the camera to record the screen and using the camera in the Scratch project. So to add video sensing, to add the video camera to the Scratch code, you need to go down to the bottom here. So here you've got your code blocks in categories. You've got your code window here, and this is your stage with any sprites that you're adding to the screen. So if you go and click on Add Extension, that's the purple block there, you can see that there are different extensions that you can add to Scratch to use in your project. The one we're using is video sensing. So you just click on that, and it adds these blocks, makes them available to Scratch. And you can see it's about video motion, and video motion would be greater than 10. Now I take that to mean that there's the movement is not just insignificant, it's greater than a certain amount of movement. So just breathing could be, it could trigger something happening if you just move slightly, and you wanted to make sure that it's above a certain value. You've got your video motion on the sprite. So this is where, for example, if I move my hand above the sprite is the classic kitty for cat for Scratch. There's a block for turning the video on and for setting video transparency. So let's get into some kind of project that you can create. You probably need to start with an event. So either sort of on clicked or on something, the game is going to start. So that's when you click the green flag, that will start the game. All of this code that I'm explaining now, you probably need to explain to students. Or you can give it to them as starter code in a file or in an image or something that they need to then copy in. And they need to kind of look at the code and figure out what's going on. Or you need to explain to them what's going on. I generally tend to explain more if it's very new. So using the video is very new. They haven't added extensions to Scratch before, so I need to show them how to add an extension, that kind of thing. If you're heavily scaffolding something, you probably want to explain more. Otherwise, you might want to give them some code and try and get them to read the code and understand the code before modifying it. So when it's clicked, we're going to go into our video sensing, and then we're going to turn the video on. And what I did when I put this project together is I left out the score, and I got them to figure out how to add a score to the project. But if you're going to do everything up front, then you might want to go to variables and make a variable, call it score, and make sure that the for all sprites is ticked so that when you run this code, it'll be for all the sprites that you might have on the screen. You click OK, and then you can, right at the beginning of the program, you can set the score to 0. As you grab the sprites on the screen, you're going to want to change the score by 1, effectively adding 1 to the score. You can obviously put 2 or whatever it is there. And I'm just going to put this off on one side. That's code that I'm going to want to use. I think under the events, I'm also going to need to add weighting. I'm going to, that's under control. I'm going to need to add, what else? I'm going to need a forever loop, and I'm going to need, now I can use the wait seconds as well. So, after turning the video on and setting the score to 0, that effectively resets it. After that, there's a forever loop, which basically runs code forever while you're working in that window. And within the forever loop, we're going to run the code for taking each sprite and making it disappear by grabbing it by having video motion. So the way to do that is to put in a control loop, and that is, we're going to wait until there is video motion. We go to the video motion. So the video motion is the motion on the sprite, and if you look at here, it says when video motion is greater than a certain amount. And we can't in any case drop this in here. It doesn't fit in that space. So when the motion on the sprite is greater than a certain amount. So if I'm just sitting here, you can see the cat is kind of over my shoulder. If I move slightly, I don't want it to make the cat disappear. I need to make a deliberate grabbing motion on the sprite. So the movement must be more than a certain amount. And I can do that with the operators. So if something is greater than 50, for example, if the video motion on the sprite is greater than 50. Now I'm guessing 50 might be okay. You might want to play with that, see how it works and calibrate that. And that's something you might want to get the students to do. You might want to give them, if you give them code, make that way up, and then say, well, what's wrong? Why are you not able to grab the cat? The motion has to be so fast to be able to grab it. If this is too low, then maybe just the slightest movement is making the sprite disappear. So we're going to wait until there's motion on the sprite, and when there is, we are going to, if you look on the look, we are going to use show and we're going to use hide. What I forgot is forever it must show the sprite, and then after it's been grabbed it must hide the sprite. So if I move now, for example, and I move it over the sprite, it should be grabbed. Oh, I forgot to click motion there. So, and you'll notice it disappears for a moment and then comes back again. So we're going to need to make it wait for a little bit. So after it's hidden, it must wait for, let's say, 1 second. So now if I move, got to press the stop it and press that again, and now it disappears for a second. You might want to use an operator to randomize that. So you might want a random number of seconds. So some it will hide for 1 second, some it will hide for 10 seconds. And you can get students to change that to their taste. Maybe they don't want to wait so long for the sprite to reappear. A crucial element to adding engagement is, of course, sound. So if you click on sound, you can see that you can play a particular sound until it's done. So I can, when I hide it, I want to play a particular sound. You can record some sound, or you can go and add a sound. So at the moment, let's stop that and go again. You can see it makes the kitty disappear, and now it's reappeared again, and it's inside the loop. So it generates, waits a number of random seconds, then it shows the icon again. And of course you can position the sprite somewhere on the screen. I moved, and you can headbutt them and do whatever you like. It's quite an engaging little game, quite annoying if you've got a sound like that. And once you put that together, we need to change the score. So when we play the sound or when we hide, we can also play the score, and then it generates a new one. And you can see every time that I headbutt the kitty, it adds a new score. And of course you can change that, you can change the sprite. So if you click on the dustbin right at the beginning and you delete the sprite, you can go and you can add a new sprite. Sorry, I did that a little bit too fast. So you choose a sprite and you click the hourglass, and you can go and create an apple, for example. And then of course you need to add the code to that. You'll notice now, no matter what I do, the apple doesn't go away. It's the cat that's going away. So once you create it for one sprite, you can duplicate it either by adding a different type of sprite and putting in the code again, essentially so that it runs for each sprite, or you could right click and duplicate. So you might have 2 cats now, and you can duplicate again, and you've got 3 till you've got the 9 cats of Kilkenny. And then obviously you can, I need to start the game again. Now I can do that kind of thing, and I did 3 of them, so the score is 3. And I think you can see that this presents quite an engaging project for kids to get into, and it introduces quite a few programming principles. So before you do the programming, you could probably go in and discuss things like a forever loop. What is a forever loop? What does it do? Or the making of a variable, score, and with how you add score. You might look at this whole notion of if something is greater than something. So a conditional statement, when it's greater than this, then it's going to wait until that condition has been met. So those are all concepts that students might be familiar with already, in which case you don't really need to introduce them, or you might want to introduce, if it's a new concept, then you want to introduce it before going through the code with them. If they are very familiar with the code, you might want to give them this code and ask them to modify it, to tweak it, to make it their own. Now, unfortunately, I don't think there's a way of changing the sprite here so that you could just go and change individual ones into different sprites. You kind of need to add them and set them up from scratch. But you can, if you notice you're choosing a sprite, you can go and paint and you can add it yourself. I'm not sure what Surprise does. So I think this is quite a nice little project. It introduces a great deal of interactivity into a lesson, and students tend to have a lot of fun with this. Be prepared for them not to want to leave your class when the bell goes. It's that addictive. So that's all for this week. If you've enjoyed this podcast, please hit like, please subscribe to the channel to get notifications when the next podcast drops, and please like and please share and leave comments. It would be lovely if people left comments about ideas of how to use this for more extended lessons, maybe how this is best taught. Let's have a real discussion about this, and see you next time.